Cambridge Assessment Admission Testing, 6th Term Examination Paper Step, 2019 Paper 1, Mathematics 1, Code number 9465, Section A. The link to the question paper is in the description below. Hi, I am Babak. In this video I am going to solve the 6th problem of this past paper. Okay, let me read the question for you. I will read it part by part and then try to solve it and then go to the next part, okay? In both parts of this question, x is real and theta is between 0 and pi, the first and the second quadrant. Part 1. By completing the square, find in terms of theta the minimum value as x varies of 9x squared minus 12x cosine theta plus 4. Okay? So this is my expression, 9x squared minus 12x cosine theta plus 4. And I want to use the method of completing a square to be able to find the minimum of this quadratic term. So I can write it in this form. I can write 9x squared minus 12x cosine theta, and then I can add 4 cosine to the power of 2 theta, and I subtract the same thing, minus cosine to the power of 2 theta, and then I have a 4 at the end. Yes. So what I have done, I have added this term and subtracted the same term, and then I have a 4 at the end. So what you see here is exactly this expression. But what is the good point here? The good point here is that this one and this one and this one will form a complete square for me. Yes, so I can write it as 3x minus 2 cosine theta to the power of 2. Yes, and between these two terms, to simplify it, I can factor a 4 out, so then it becomes 1 minus cosine to the power of 2 theta. Let me double check what we have done is completely correct. So if I expand this if I expand this binomial, you will see that 3x to power 2 will give me 9x squared, and then I have 2 times the first one times the second one, which will give me this term. And then finally this term to power 2 will give me this one. So what I have done is completely right. But then this last bit, we have a formula for this. This is sine to the power of 2 theta. Yes, so I can just write it, and then we can have 9x squared minus 12x cosine theta plus 4 is equal to 3x minus 2 cosine theta to the power of 2 plus 4 sine to the power of 2 theta. Okay, that's the expression I get. Okay, but my goal is to find the minimum value for this expression, and then you can immediately see that this expression, because of this even power, is non-negative. So this means that this expression as a whole is greater than or equal to 4 sine squared theta. Yes, so it means that what I get is that 9x squared minus 12x cosine theta plus 4 is greater than or equal to 4 sine to the power of 2 theta. Because we are talking about minimum, we have to make sure that this minimum is actually achieved, yes, is attained. So here, if you look here, for this expression to be exactly 4 sine squared theta, this should be equal to 0. Is this possible that this expression be equal to 0? Yes. It is enough to choose 3x equal to 2 cosine theta. Then this becomes 0, and actually this minimum value is attained. So from this we realize that the minimum of this expression for a given theta is equal to 4 sine squared theta. Okay, and this minimum, let me write it here, and this minimum occurs if and only if if and only if 3x minus 2 cosine theta is 0. So if and only if x is equal to 2 over 3 cosine theta. Okay, so what we answered is that this is the minimum value required by the question, and then when this minimum occurs, for the next part it would be needed, you will see. So I am seeing that, okay, this becomes equal to that, this is the minimum, and this minimum is obtained if this x is equal to 2 over 3 times cosine theta. Okay, and now if you go to the next part of the question, find also the maximum value as x varies of 12x squared sine theta minus 9x to the power of 4. Okay, so this time I want to find the maximum value, and then probably you see why, because this x to the power of 4 has a negative sign. So if you want to complete the square term will have a negative sign, and this will give you the maximum value. Okay, so let me write it down here. So the expression that I am interested now is 12x squared sine theta minus 9x to the power of 4. For me, it's easier to take the negative sign out first, so then the term becomes 9x to the 4 minus 12x squared sine theta. I more or less use the same strategy for completing squares, so I will have minus 9x to the 4 minus 12x squared sine theta. Then I will add 4 sine squared theta, and then I subtract it. Okay, and then you immediately realize that I can write it as negative. These three terms, this one and this one and that one, again can be written as a complete square. So I can write it as a 3x squared minus 2 sine theta to the power of 2. Then I will have minus 4 sine to the power of 2 theta. Let us double check everything. This 1 to the power of 2 will give me 9x4. 2 times the first one times the second one will give me exactly this term. And finally this term to the power of 2 will give me this. Okay? And then now I can multiply this negative sign back. So negative sign by negative sign becomes positive. It becomes 4 sine to the power of 2 theta minus 3x squared minus 2 sine theta to the power of 2. Yes. So what we got is this: 12x squared sine theta minus 9x to the 4 can be written in this form: 4 sine squared theta minus 3x squared minus 2 sine theta to the power of 2. Yes, so this is the expression that we get for this new expression. Okay, but now you realize that again, because of this even power 2, this expression is greater than or equal to 0. So if I consider the whole thing, it becomes less than or equal to 0. So this means that this expression is always smaller than or equal to this expression. Yes. So let me write it here. So this means that 12x squared sine theta minus 9x to the power of 4 is smaller than or equal to sine to the power of 2 theta. But can this equality indeed hold? The answer is yes. It suffices to choose 3x squared equal to 2 sine theta. If you choose 3x squared equal to 2 sine theta, then this becomes 0, and then you can get this minimum value, this maximum value. Okay, so if I want to answer this question, the maximum of 12x squared sine theta minus 9x to the power of 4 is 4 sine squared theta. Yes, so this is the maximum value for this. So if I put this in a box here, and then let me also put this one in a box, and then let me add a sentence, and this maximum occurs if and only if what happens if and only if this term becomes 0. So it means that x squared should be 3, so let me write it here for you. So if and only if 3x to the power of 2 minus 2 sine theta is equal to 0. And this happens if and only if x squared is 2 over 3 sine theta. Yes. Okay, now let us go to the next part of the question. Hence, determine the values of x and theta that satisfy this equation. Okay, because of this word hence, and usually this is a typical situation in STEP exams, so when you solve the problem, so this is somehow a hint how to solve the next part. Okay, so it's a good idea to realize that this expression here is actually a combination of this expression and that expression. So it might be helpful. So let us see how we can use that. So let me write this equation in front of our eyes. Let me change the color. So that's the question itself. So I am supposed to solve this equation, 9x to the power of 4 plus 9 minus 12 sine theta to the power of 2 minus 12x cosine theta plus 4 equals to 0. Yes, so I want to solve this equation. Okay, that was my goal. Okay, and then here I can write this equation in this form. So let me continue this one here for you. So if I multiply things inside, so it becomes 9x to the 4. I will expand this. 9 times, oops, I made a mistake, I think. Yes, that's x squared here. This is x squared. Okay, so I multiply this thing inside, so it becomes 9x squared. And then I will have minus 12x squared sine theta. And then I will have minus 12x cosine theta, and then I have 4 equals to 0. Okay, so now you can see that you can recognize this. So here, this term is this term here, and this term is also this term here. So if I move them to the right hand side, this one becomes positive as exactly here, and this one becomes negative as it is exactly here. Okay, and then what is left for you is actually, I will show you shortly. So let me move them to the right. Then I will have 9x to the power of 2 minus 12x cosine theta plus 4, and then I will have on the right hand side, I will have positive 12x squared sine theta, and then I will have minus 9x4. Yes. Okay, but now look, this one is exactly this expression, and we know its maximum is 4 sine to the power of 2. Okay, so what we know about this expression is always smaller than or equal to 4 sine to the power of 2. Yes, this is the maximum value that the right hand side can attain. But let us look at the left hand side. So you see, so try to remember this. Okay, this one is exactly this expression. Yes, so let us check it again. So 9x squared minus 12x cosine theta plus 4. Look here, 9x squared minus 12x cosine theta plus 4. That's exactly the same expression. Here we realize that the minimum of this expression is this. So what does it mean? It means that this expression is always greater than or equal to 4 sine to the power of 2. Okay, so what we learn from here is that I have an equality here. I want to make this equality happen. On the other hand, I know that the left hand side is always greater than or equal to this, and the left hand side is always smaller than or equal to the same value. So this equality happens if and only if they are equal to this common value. Yes, so this equality happens if and only if 9x squared minus 12x cosine theta plus 4 is 4 sine to the power of 2 theta. Yes, and then 12x squared sine theta minus 9x4 becomes equal to 4 sine to the power of 2 theta. This happens if and only if, and of course both of them happen simultaneously. But then let us go back here. So when this happens, yes, so I have written it here for you in this sentence. This minimum occurs if and only if x is equal to 2/3 of cosine theta. So here I would continue and say that x, if this happens if and only if that x is equal to 2/3 of cosine theta. Yes. On the other hand, I have just written here when this occurs, when this equality occurs. This equality occurs if and only if x squared is 2/3 sine theta. So I would write that this equality, the second equality, happens if and only if x squared is 2/3 of sine theta. Okay, so it means that I need to solve a system now containing these two equations. Yes, x is 2/3 of cosine theta. On the other hand, x squared is 2/3 sine theta. Yes, so let me move these two equations to the other page. Yes, so I would start solving this. X is 2/3 cosine theta as my first equation. Yes, the first equation. And the second equation, x squared is 2/3 of sine theta. X squared is 2/3 of sine theta. So x squared is 2/3 of sine theta. Yes. So then this is not hard to solve. So what I do, I use the substitution method. Yes. So what I do, instead of this x, I put this value. Okay. So what happens? It becomes 2/3 cosine to the power of 2 to the power of 2. Cosine of theta to the power of 2 is equal to 2/3 sine theta. So then it gives me 4/9 cosine to the power of 2 theta is equal to 2/3 sine theta. Yes. And then I can multiply both sides by 9, so I will get 4 on the left, and instead of cosine squared I just write 1 minus sine to the power of 2 theta, and when I multiply it by 9 the right hand side becomes 6 sine theta. Okay, so I can arrange it as a quadratic equation, but of course I can simplify by 2, so it becomes 2 sine to the power of 2 theta plus 3 sine theta, and then I will have minus 2 equals to 0. Yes, so I simplified everything by 2. I multiplied the 2 inside and I moved everything to the right hand side. Yes. Okay, and now I need to solve this, but this is a quadratic equation for sine, so sine theta becomes equal to minus 3 plus or minus square root of 9 plus 16 divided by 4. So it becomes minus 3 plus and minus 5 divided by 4. So I will get two numbers. One of them is minus 3 plus 5 divided by 2, which becomes 1 over 2. The other one is minus 2, which of course this one is not acceptable because sine cannot be negative 2. Yes, so what I get is that I immediately get that sine theta is equal to 1/2. Yes, and then if you look at the question, theta is supposed to be between 0 and pi, so what I get back is that there are two answers. Either theta is pi over 6 or theta is equal to 5 pi over 6. So these are the theta values, but I also need to find the x values. Okay, that's very easy. So I put theta, for example, pi over 6 here, and I calculate my x. Then I put theta 5 pi over 6 here, and then I calculate my x. Okay, so if theta is pi over 6, then what can I conclude? I can say that x is 2/3 of cosine pi over 6. So it becomes 2/3, and then this becomes square root of 3 over 2. So this means that theta is pi over 6 and x is equal to square root of 3 over 3. So that's a pair of solutions. Another pair is that when theta is 5 pi over 6, then x becomes 2/3 of cosine pi over 5 pi over 6. So it becomes 2/3 minus square root of 3 over 2. Yes, the cosine of 5 pi over 6 is cosine pi minus. So by the way, we can see that 5 pi over 6 and pi over 6 are supplementary angles. So the cosine of one of them is the negative of the cosine of the other one. Okay, so what you can conclude is that the other solution is theta is equal to 5 pi over 6, and x, of course, in this case would be negative square root of 3 divided by 3. So these are the pairs of numbers that we get for x and theta respectively. Okay? Okay. Now we go to the next part. So to the next part, part 2, sketch the curve, this, where theta is a constant, of course a constant between 0 and pi. And we are supposed to conclude that either this happens or that one happens. So this part should be based on your ability to sketch the graph and use the information on the graph to conclude these two inequalities. Okay. So we have y equals to x squared over x minus theta. Okay, so if I want to sketch the graph, usually I immediately try to find the equations for the asymptotes. Okay, so then these kind of functions are famous. The degree of this expression is 1 unit, exactly 1 unit more than the degree of this. So there is an oblique asymptote for this function, and of course x equal to theta is the vertical asymptote for this function. Okay, so the vertical asymptote is clear, but if I want to find the oblique one, so either you use the long division of x squared divided by x minus theta, but this is very simple here. If you can just see that, I can subtract theta 2 in the numerator and just add it and then divide it by x minus 2. Why this is helpful? Because the first part you can factorize using the conjugate rule. You see, I subtracted minus theta and I add the same thing to compensate for that. So what I have done is actually nothing. X squared is still x squared. But the benefit of doing that is that in these two terms I can use the conjugate pattern, and then I will have theta squared at the end divided by x minus theta. Now if I divide this separately by that and this by this, in the first one x minus theta and x minus theta will be cancelled. So let me write it once more. So x minus theta, x plus theta divided by x minus theta, and then I will have theta squared divided by x minus theta. So here this x minus theta and x minus theta are gone. So what I get is x plus theta and then plus theta squared divided by x minus theta. So this gives me that y equals to x plus theta is the oblique asymptote. Okay, so this is my oblique asymptote. And x equal to theta, of course, is the vertical asymptote. Okay, so this is my vertical asymptote and that is my oblique asymptote. And then when I want to sketch the graph, usually it's easier to take the derivative. And I would say that taking the derivative of this form is much simpler. So let me just use this expression, use this form to take the derivative. It's easier from calculational point of view. So the derivative of x is just simply 1, the derivative of theta is 0, but then the derivative of that expression becomes minus theta squared divided by x minus theta to the power of 2. So, and if I equate it equal to 0, so because I want to sketch the graph, so let me do the common denominator. So then it becomes x minus theta to the power of 2 minus theta 2. So if you expand it using the quadratic pattern and then you simplify it, it becomes x squared minus 2 theta x, because theta is squared and theta x squared are gone. And then one more step, I can take x out, it becomes x minus 2 theta divided by x minus theta to the power of 2. And then when I equate y prime equal to 0, this means that x times x minus 2 theta is equal to 0. Then it means that x is equal to 0 or x is equal to 2 theta. So these are my candidates, possible candidates for local maximum or minimum points. Okay. Okay, so if I want to sketch this graph, so I can set up a table of values or signs here. So here I have x, and then 0 and 2 theta are two numbers, but then you see that theta is also my vertical asymptote, so the function is not defined here, the function is not defined at theta. So here I have the derivative and here I have y, and by the way x goes from minus infinity to plus infinity, but the function, if you see this function, if I send x to minus infinity, this term will vanish, but this becomes minus infinity, so it means that I have minus infinity here. And if I send x to positive infinity, this term will vanish, then I will have positive infinity. So here I will have positive infinity. But what type of infinities do I have on the left hand side and the right hand side? For example, if I want to understand what is the behavior of my function close to theta on the left hand side, what I need to do, I take the limit of my y and I will send x to theta from the left. Then what happens here, this becomes just 2 theta, but this one becomes number a theta squared divided by 0, not 0, infinitesimal small number, infinitesimal number. So then x minus theta, because x is on the left hand side theta, it becomes a negative infinitesimal. The numerator is positive, so it becomes negative infinity. Yes, so this becomes negative infinity, so what I put here is negative infinity. And then for the same, on the same line of argument, you can just see that this becomes positive infinity if x goes to theta from the right. So this becomes positive infinity here. At these 2 points, the derivative is 0, but it is very easy. Just look here. The denominator of the derivative is positive, so this is my derivative. Between 0 and 2 theta, what is so after 2 theta, yes, if x is bigger than 2 theta, so then definitely the derivative is positive. And if x is smaller than 0, this is already smaller than 0, so it becomes positive again, so this is also positive. Yes, but you will get a negative value for derivative here and there. Okay, and then of course, if I go back to my function, if I put x equal to 0 in my function, what I get is just 0. So it's easier to put it here. If I put x equal to 0, then y is equal to 0. And if I put x equal to theta here in my function, then it becomes 4 theta. Yes, it's easy to see that this becomes 4 theta. So here the function goes up, the function goes down, the function goes down, and the function goes up. So you see that this point is a local maximum point, and this point is a local minimum point. So 0 and 0, a local max point. Yes, and then 2 theta and 4 theta, a local mean point. Yes, so if you don't mind, let me take all these information with me to the next page to have it in front of our eyes. Yes, and so try to copy it and make it smaller if possible. Yes. I don't know why this rotated. Okay, so yes, a little bit smaller. Yes, good. Okay, so this is the information that I got so far, and then using this I can try to sketch the graph. Yes, so let us try to do that. So here let me draw my coordinate axes. So here and there we have these coordinate axes. So this is the x-axis and this is the y-axis. Okay, so let us consider that this is the length of theta. Yes, so then it becomes 2. So here if I consider this theta, then this becomes 2 theta. Yes, and then first of all, do you remember I had 2 asymptotes, one of them vertical, so let me write my function here as well. So my function was x squared divided by x minus theta, if you remember. Okay, what I got is that I have a vertical asymptote, and that was x equal to theta. So this is my vertical asymptote. Yes, and then I have the oblique asymptote. So if you remember, let me write the equation. The equation was, let's go back and see that. So you see the equation was x plus theta here. This is my oblique asymptote. Okay, so if we go back, then we will have this one. So y equals to x plus theta was my oblique asymptote. So it's very easy to draw that one as well. So x plus theta passes through this point and that point. So if I connect them, so let me use this tool, it's easier, might be, yes, good. So that would be my asymptote. So this is y equals to it's y equals to x plus theta, and then this one is x equal to theta. And then what is the minimum point? The minimum point is 0 and 0, which is the origin. So this is my minimum point. Let me change my color. Okay, so this is my minimum point. So around this, my function should behave like this. And then what is the other point? 2 theta and 4 theta. So where is 4 theta? So 4 theta, this 1, 2, 3, and 4. So this is 4 theta. Okay, and then this is a local minimum. Okay, and then you can immediately realize that this is somehow the sketch of your function. The function will behave like this. Yes, and then it goes up here, and then it goes asymptotically close to this asymptote. Okay, it's not a very good picture, but hopefully you understand what's going on. Okay, and then let me write this 4 theta. Okay, so this is more or less the sketch of this graph. Okay, now let us go to the next part of the question. So here, sketch the graph. We already done that. This orange one is the sketch of my graph. Theta is of course a constant, and then deduce that either x squared over x minus theta, which is exactly the function, is less than or equal to 0 or greater than or equal to 4 theta. But it is completely clear, yes, because these branches of my graph are two parts. So one part is below the x-axis, so this part is below the x-axis, so the y value of all these points are smaller or equal to 0, and the y value for all these points lying on this branch is above this horizontal line, which of course is y equal to 4 theta. So it is immediately clear that if you are working here on this branch, then x squared over x minus theta is less than or equal to 0, and if you are working here in this branch, if you are on that branch, and then x squared divided by x minus theta is greater than or equal to 4 theta, sorry. This is 4 theta, yes? So that was easy. Now let us go to the next part. By considering the numerator and denominator separately or otherwise, show that sine squared theta cosine squared x divided by 1 plus cosine squared theta sine squared x is less than or equal to 1. Yes? Okay. So if we want to do that, we can write it as follows. So let us simplify, for example, the denominator, because you see this is sine theta cosine x, but here we have cosine x and cosine theta and sine x. So it might motivate you, for example, if you go to the denominator, you can change sine squared to cosine squared and cosine squared to sine squared to make them the same as the numerator so that we can compare them. Yes. So let me just do that. So the denominator is 1 plus cosine to the power of 2 theta, and then I have sine theta. Or let me do it in a different way. So let me write this: sine to the theta x, and then what I have here is 1 plus cosine to the power of 2 theta sine to the power of 2x is less than or equal to 1. But of course this is a positive expression, so this is equivalent if and only if this happens. Yes. Yes, this happens if and only if this. And then this is also happening if and only if on the left hand side, instead of this, I put 1 minus cosine squared theta, and instead of this I put 1 minus sine squared x. So let me just write it. So this if and only if 1 minus cosine to the power of 2 theta, yes, and then times 1 minus sine squared x is less than or equal. I just copy and paste the second part, the second hand on the right hand side. Sorry, the right hand side. So sine squared x. Then this is equivalent. I can multiply the left hand side, so it becomes 1 minus sine to the power of 2x and minus cosine to the power of 2 theta plus cosine to the power of 2 theta sine to the power of 2x is less than or equal to 1 plus cosine to the power of 2 theta sine to the power of 2x. This is equivalent. You see, this one and that one are simplified. This expression is exactly this one. They are gone. So what is left is this. If and only if minus sine squared x plus cosine to the power of 2, minus cosine to the power of 2 theta is less than or equal to 0. And this is if and only if I multiply both sides by a negative sign, it becomes this. Yes, so and that is always true, yes, because this is non-negative because of this even power. This is also non-negative because of this even power, so the sum is non-negative. And then if you see, all the arrows are double-sided. So this expression is equivalent to this expression. But this is trivially true, so this means that this is also true. Yes, so I would say that this is one type of proof for this part of the problem. Okay, now we go to the last part of the problem. We are supposed to solve this equation for x and theta. Okay, so if you look here, this expression is exactly this expression here, which we already know is less than or equal to 1, but of course we know that this is also greater than or equal to 0, because the denominator is positive and the numerator is a non-negative number. Okay, so this expression lies somewhere between 0 and 1. Yes, but now look at this expression. This expression is comparable to this expression except for this extra factor of 4 theta in the denominator. Okay, but it's easy to produce this factor here in the denominator. So for example here, because theta is supposed to be a positive number, this is equivalent. If I divide both sides by theta, 4 theta, it becomes x squared divided by 4 theta. X minus theta is less than or equal to 0. Okay, and here if I also do the same thing, if I divide both sides by 4 theta, it becomes x squared divided by 4 theta. X minus theta is greater than or equal to 1. So what we'll realize for this, we see that this expression is either greater than or equal to 1 or less than or equal to 0. So the left hand side is either greater than or equal to 1 or less than or equal to 0. On the other side, we have this expression which is less than or equal to 1 and greater than or equal to 0. So if these two are supposed to be equal, they have to touch each other exactly at the borders. So it means that either both of them have to be equal to 0 simultaneously, or both of them have to be equal to 1 simultaneously. Okay? But here, this expression, let me write it here, x squared divided by 4 theta, x minus theta, is equal to 0 if and only if x is equal to 0. Yes? and then x squared divided by 4 theta divided by x minus theta is greater than or is equal to 1 if and only if x is 2 theta. Why? Because you see this expression is equal to 4 theta only at this point where x is 2 theta. So it means that this expression is equal to 1 if and only if x is equal to 2 theta. Okay? I will use all of these information to be able to solve the last part of the problem. Okay? So, let me give this a name. For example, I can put a star here. Let me change my color. So I put a star here. I would say that star happens if and only if both of them are equal to 1, okay, x squared divided by 4 theta x minus theta, let me write first 0, either both of them are equal to 0, yes, is equal to 0, or both of them are equal to 1, yes, is 1 and sine to the power of 2 theta cosine to the power of 2x divided by 1 plus cosine to the power of 2x theta sine to the power of 2x is equal to 1. I realize that I have made a mistake. This is not sine, this is cosine. Yes, okay. But now look here, this is equal to 0 if and only if x is equal to 0. So this happens if and only if x is equal to 0. But what about this one? This happens if and only if the numerator is equal to 0. This happens if and only if either sine of theta is equal to 0 or cosine of x is equal to 0. Okay? But of course, this cannot happen because it was mentioned in the problem that theta is strictly between 0 and pi. So this cannot happen. Yes, cannot happen. Yes, and then this one and this one cannot happen simultaneously, because if x is equal to 0, then cosine has to be equal to 1, so it cannot be equal to 0. So it means that this star happens if and only if this happens or this happens. But the first one totally cannot happen, so it means that I need to consider only this case. Yes. So I would say not possible here. Okay, so I need to only consider this situation. Okay, but then according to what I have written here, look here, this expression is equal to 1 if and only if x is equal to theta. Okay, so what can I write? This happens if and only if x is equal to theta. But what about this one? So I don't want to do everything again, but look here. Assume that this one, instead of inequality, I have equality. Then this one becomes equality, then the next one becomes equality, until the end this becomes equality. So if I change this with equality, which is exactly this expression, this becomes equivalent to this expression for instead only I will have equality. Okay, so this implies that this happens if and only sine squared x plus cosine to the power of 2 theta is equal to 0. But then this is a non-negative number because this is even power. This is also a non-negative number because this is even. So it means that the whole expression is non-negative. So it means that a non-negative, so the sum of two non-negative numbers is equal to 0. So this happens if and only if each one of them individually is 0. Oh, sorry, not or and cosine theta is equal to 0. But then this is equivalent to saying that x is n pi, where n is an integer, and theta is pi over 2, because theta is between 0 and pi, so the only number whose cosine is 0 is pi over 2. Okay? Okay, so then it means that this last bit is this. X is supposed to be equal to 2 pi theta from the first one, and x on the other side should be equal to n pi for some integer, so x is equal to n pi where n is an integer, and theta is equal to pi over 2. But then you see that if theta is pi over 2, if I put it here, x becomes pi. And for no other values for n, I can have all these inequalities satisfied. It's very clear, yes? So it means that the only value is that, so I would say that a star happens if and only if x is equal to pi and theta is equal to pi over 2. So that would be the last part of this problem. Okay, I hope that this video was somehow helpful for you. Thank you for listening to me and watching my video. If you think that this video was useful, please give me a thumb up. And if you think that I can help you with other questions from STEP exam, please just write a comment below this video. I will try to make a video and solve that question for you. Okay, thank you very much and good luck.